All right, so we're going to tackle another piece of the chain rule that involves trigonometry today. So I just want to stress this saying that every time when we're using this chain rule, we're saying derivative of the outside, keep the inside, times the derivative of the inside. And again, I'll just kind of go over the notation, and they're going to use something like f of g of x, because you can see that g of x is inside f of x. So the derivative, so this would be my inside function. This would be my outside function. Derivative of the outside, keep the inside, times the derivative of the inside. And we're just going to keep repeating that to ourselves over and over and over. So now, when we talk trigonometry, you're going to see something like the sine of 7x. And again, I think the inside is going to be semi-obvious because it has we could put the parentheses in there and you'll see that this is inside. And my outer function would be the sine function. Okay, so that's kind of what we'll be dealing with in this series today. Oh gosh, I picked the same one. Number 1, the sine of 7x. All right, so for our first example, again, my inside is 7x and my outside is sine. So when I go to take the derivative, I'm going to say, what is the derivative of the outside? So now go back to your trig derivatives. We just did those the other day. The derivative of sine is cosine. So now the only thing is we're not going to put the cosine of x because we're saying keep the inside. And my inside isn't just x, my inside is 7x. So it's the cosine of 7x times the derivative of the inside. So if it helps, you can write your inside function down. So my inside function is 7x. So its derivative then is just 7 because it's linear. And I will rewrite it by just pulling the coefficient in at the beginning. You cannot take anything out of this 7x. You cannot put the 7 into the 7x because this is only the cosine of 7x. So I can rewrite this as 7 cosine of 7x. Again, nothing can go into the of part. Anything else just gets pulled in front as a coefficient. Number 2, g of x equals 3 cosine of 8x. So I just want to be clear that this is not a product rule because although it looks like 3 times, this first term does not have an x associated with it. So because this is just a coefficient, when I derive it, it's going to be part of my outside function. So g prime of x equals, and again, it's chained because there's an inside, the derivative of the outside, keep the inside, times the derivative of the inside. So if it helps, if your inside, if you rewrite it for yourself, is 8x, its derivative, this is linear, is just going to be times 8. So again, nothing can go into the of part. The only numbers that can get multiplied are these two. So g prime of x is equal to 24 cosine of 8x. Now, on just a side note, you might be thinking, well, didn't the other functions, the trig functions we did already have an inside? Like if I said g of x equals just the sine of x, I mean, technically that x is inside. Well, watch what happens when I take this derivative, g prime of x. The derivative of the outside is cosine, keep the inside, and now the derivative of just x, of course, is 1. So we were technically doing chain rule. We just hadn't called it that because its inside derivative was 1. So the derivative of sine, of course, is cosine. We just weren't showing the chain rule at that point. All right, let's take a look at this one. So we've got 2 pieces. So all we're saying when they're separated by a plus or minus sign is we're just going to attack them separately. No big deal. So let's start with this first piece. This is just a 4, so it's a coefficient, not a product. And I see sine of 3t. I guess another hint you could write down for yourself is anytime you say that word of, that's an indication that you should be using chain rule. Okay, anytime you say the word of. So if you remember, I said a lot of self-talk, you need to read these out loud to yourself, and it's okay to whisper during a test. It's really important that you're catching these terms. So I'm going to say this derivative is the derivative of the outside. Remember, that's a coefficient, so it stays. The derivative of sine is cosine. Keep the inside times the derivative of the inside. So if my inside is 3t, that's linear, its derivative is just 3. Okay, so I'm going to keep my minus sign now, and I'm going to check out this term. 10 is just a coefficient of the cosine, so that 10 is going to stay. The derivative of cosine becomes negative. It starts with the C, negative sine. Keep the inside times the derivative of the inside. So if I have 7t squared, that's the power rule, its derivative is 14t. All right, now, things that you might have skipped over that are super important. Notice when I took the derivative of cosine, I put parentheses around this. Because if you wrote this, 10 minus the sine of 7t squared times 14t, you are now telling the grader that you want to take 10 and subtract sine of t, where that's not what we're saying at all. We want to do 10 times the sine of negative sine of 7t squared. This is telling the grader you want to subtract. This is telling the grader you want to multiply. And it makes a huge difference, obviously. All right, so now we'll just work on the cleanup part. So f prime of t, what can get multiplied together? So remember, nothing goes into the of part, so just these outside terms. So I'm going to say that's 12 cosine of 3t. Now I'm going to check out my outside terms. Technically outside here, I have, I have a 10, I have a -1, and I have a 14t. So I'm going to pull that out as a negative. So these two negatives are going to make a positive. 10 times 14 is 140t. And then the sine of 7t squared. Now, the only other thing they're going to do on a lot of multiple choice, and this is, like, again, the calculus is perfect. Now it's just simple algebra cleanup. You could factor out a 2 goes into both of these, so you could easily pull out a 2 as a GCF. So if I wanted to, I could say this is 6 cosine of 3t plus 70t sine of 7t squared. Okay, so they can pull out GCFs, and you'll see that on multiple choice questions a lot. Your calculus is probably right. It's just a GCF that follows. All right, f of m equals 5 secant of 4m. So again, I'm assuming that we're familiar from Algebra 2 here. F of m is implying that m is the variable in the function. It really makes no difference whether they use theta or t or p or x or z, whatever. But we do want to make sure this variable matches up. All right, so we have got, let's see, 5 secant of 4m. Notice again, I'm reading out loud to myself, and you should be doing the same thing. All right, 5 is just a coefficient because it does not have an m with it, so it's just going to stay. So f prime of m equals, we're going to keep the 5. So now here's my outside and my inside. The derivative of my outside, so secant, if you kind of look back at your notes, the derivative of secant is secant x tan x. However, instead of saying x, we're saying keep the inside. So this is going to be the secant of 4m and the tangent of 4m, because we're saying keep the inside times the derivative of the inside. So if the inside is 4m, that's linear, its derivative is just 4. And then again, nothing can go into the ofs, so I can multiply these terms together. So f prime of m is equal to 20 secant of 4m tangent of 4m. Okay. And just to be clear, there's no GCF I can pull out because there's no plus or minus sign, and nothing can go in or out of the of, so you really can't touch those at all. So we've got question 5 here. Feel free to look back at your derivative of trig functions notes and try to just take this derivative on your own. So pause it and give it a whirl. All right, so take a look at my derivative. I kept my coefficient of -10. The derivative of cosecant is negative because it starts with a c, so there's my negative. Cosecant, cotangent, and again, we're doing chain rule, so we're keeping the inside. And remember, pi, they're just going to try to mess with you. Pi is just a constant, 3.14159, 265, blah, blah, blah. So the derivative of pi x is linear, so just times pi. And then lastly, we'll go ahead and clean that up. So f prime of x is equal to, I can multiply these and this negative. So I'm going to get a positive 10 pi. Cosecant of pi x, cotangent of pi x. And again, when I see the cos, all the cos are in the same one. Cosecant, cotangent. It's kind of my trick to memorize them. Likewise, try number 6 on your own. Pause it and see how it goes. So I've got mine worked out here. Again, the coefficient is 6. Tangent is 1 term squared, so it's secant squared. I know it's not a co because it didn't start with a co. Keep the inside times the derivative of the inside. And then again, I'm just going to pull out the coefficient. 6 times 24 is going to get me 144. X to the 7th, secant squared of 3x to the 8th. So if you were thinking that's been pretty simple so far, doable, we're getting into the big bears here now. These are kind of like a double chain rule. And you've got to rewrite. That is the key. It all comes back to rewrite, rewrite, rewrite. Now, what gives it away as a double chain rule is that clearly you see this as an inside, correct? And now you have this squared. So we've got to rewrite this. So watch how this gets rewritten, and I can show you where the double chain rule is taking place. So here is the rewrite. F of x equals 3. Now notice the squared is on the sign. It is not on the 3. So I need to put a bracket because it's not on the 3. So this is the sine of 7x cubed squared. So let's just take a moment in and talk about how we rewrote this because this is a double chain rule. The squared is not on the 3. So the 3 stayed outside. It's on the sine. So I put a bracket around the sine function. I have my 7x cubed here, and the squared goes outside. Now, why am I saying it is a double chain rule? Do you see it's a double chain rule? The first inside I have is the 7x cubed. That is inside the sine function. But now look how crazy this gets. The sine of 7x cubed is inside the squared function. So there is 2 inside terms. Okay, so we're going to start with the outer one, the outermost function, which of course is the exponent here. Okay, I probably should change my color. My outermost function is the squared. So let's watch how we derive this. Of course, I'm going to take this 2 and bring it down. So let's multiply that in our head. 6. So I took the derivative of the outside, keep the inside. You cannot touch the inside. So it's the sine of 7x cubed. And now this 2 becomes a 1. Okay. Now you go to the inside of that main function. So I'm going to go back to the first thing I read. The first thing I read is sine. Its derivative is cosine. Keep its inside. Times, now I'm going to go to the next inside, 21x squared, deriving that with my power rule. So let me just talk through it again, and we'll get a little practice here. I started with the derivative of the outer function. That came down to get me my 6. Maybe make a note. Keep the inside. Okay, so I'm going to keep the inside. I subtracted my 1. Now I go back to just the first term inside. Now I'm going to go to the first inside term. Its derivative became cosine. And again, I keep the inside. Now I go back to the next inside term and I take its derivative. So the derivative of the inside. Okay, so I took its derivative. Lastly, I just need to clean this up. What can get multiplied together? So I'm going to say 6 and 21x squared. So that's 126x squared. Then I have the sine of 7x cubed and the cosine of 7x cubed. And there's no plus signs in there. Everything is being multiplied together. So that is my final f prime of x. All right, so we'll get another 1 or 2 to practice here. But these are double chain rules. And this is pretty much as ugly as it can get for a double chain rule. All right, number 8. 7 tangent squared of 8x squared. So are we catching double chain rule? I guess that's the first question. Clearly there's an obvious inside, and then the squared is telling me it's inside something else. So let's go ahead and rewrite. So pause it, rewrite it for yourself. And I just wrote cosine, not sure why I did that. Tangent of 8x squared squared. Okay, so I'm rewriting by pulling that exponent out just on the tangent. All right, so now we're ready to tackle the derivative. So I'm going to start with the outside, derivative of the outside. Keep the inside. And this 2 now becomes a 1. Times, now I have to start on the inside function. Inside is tangent, so its derivative is secant squared. Keep the inside. Times the derivative of its inside, so power rule, 16x. Okay, so derivative of the outside, keep the inside, derivative of the inside. So when I clean up, again, I'll just highlight, I can multiply the 14 and the 16x together. So that gets me a 224x. Then I have the tangent of 8x squared and secant squared of 8x squared. And again, nothing can go into those of, so they just stay the way they are. All right, so just playing around with the little trig. So we're away from the double trig, double chain rules, and this is just a simple chain rule. Inside, outside. So we're just going to talk through it. Derivative of the outside. So the derivative of cosine starts with the c, so it's negative sine. Keep the inside times the derivative of the inside, and the derivative of tangent, remember tangent and cotangent are one term squared. So derivative of tangent is secant squared. So now again, when I clean this up, I just want to be very clear. You cannot break up the trigonometry, the sine of tangent of x. That's how it's read. Nothing can go inside that. So when I rewrite this, I'm pretty much just going to say negative, I'll pull that kind of forward as my coefficient, secant squared of x times the sine of tan x. And that would be my final answer. So the derivative of tangent, my outside is secant squared. Keep the inside times the derivative of the inside. Secant repeats itself and times tangent. And again, I just want to stress nothing goes inside here. This is read secant squared of this. So really, that is my final answer. I guess you could pull secant x, tan x in front if you wanted, but you really can't break this up. Secant squared of secant x. All right, last question, something we've been doing throughout the past few videos here. Write the equation of the tangent line and the normal line. So again, I don't care what type of line it is. Anytime you see the word line, and you're going to see it a million times, you need to be thinking, I need a point and a slope. Okay, so the point, you need an x and a y. They were very nice and gave you the x. They usually give you something. And now we'll just go get that y value. So I need f of pi over 4. So I need tangent squared of pi over 4. And again, guys, I'm going to stress that rewrite. Okay, that squared means it goes on the outside. So I really need the tangent of pi over 4 and then square that. So pi over 4, 180 divided by 4, if I picture 180 here and I cut it into 4s, that's 45 degrees. So the tangent of 45, close your eyes, picture that table of values. We got to have that memorized. We practiced a lot in algebra too. The tangent of 45 is 1. And of course, 1 squared is 1. So I've got my y value. The next thing, that was not calculus involved. The next thing I need is my slope. That's where calculus comes in. So I'm going to use my cleaned up version, of course. So it's the tangent of x squared, because that squared goes on the outside. So now it's technically a double chain rule because I have this inside, and then I have this inside, and that's my outer. So let's take this derivative. Derivative of the outside, power, so bring that down, 2. Keep the inside to the first. Derivative of the first thing inside, so the derivative of tangent, one term squared, is secant squared. Keep its inside times the derivative of its inside. The derivative of x, of course, is just 1. So I have f prime of x is equal to 2 tangent of x secant squared of x. Now I have to carefully plug in pi over 4 to get that slope. All right, so this is where that trig is just going to come back and back and back. Just got to know that table of values. So I have 2 tangent of pi over 4 secant, and again, I'm going to move that, of pi over 4 squared. I'm always putting that squared outside. All right, so picture that table of values. I need the tangent of 45, which we just said is 1. Now I need the secant of pi over 4. So secant, if I kind of flip the order of that S and C, really goes with cosine. So I want you to think of the cosine of 45. Happens to be the same as sine of 45, which is radical 2 over 2. I have to square it because it's squared. When I square a square root, they just cancel. So I get 2/4, which is equivalent to 1/2. So that's the cosine, but I needed secant, so I need to flip that, and I'm going to call that really 2. So I would say my slope is 4. So if I'm writing the equation of just the tangent line, my slope is 4. So let's go ahead and put it all together here. Y minus y1 equals the slope times x minus x1. And I'll just be clear that that's the tangent line. Then if I want the normal line, the only thing that's switching is that slope, and it's the opposite because it's perpendicular, so negative reciprocal, x minus pi over 4 for my normal. Okay, so that does it for our last video on new stuff for chain rule, and our next one, we're going to put some crazy stuff together. So we'll have a little bit of practice for you, and good luck.